Hello, my name is Vaed Kamat. I go to Rancho San Joaquin Middle School and I'm in 8th grade. Right now, you're using a computer. Computers get their Wi-Fi signal from antenna and routers. Antennas transmit and receive signals in the form of electromagnetic waves. My science fair topic is how antenna elements affect gain and radiation pattern. The purpose of this project is to maximize antenna gain to maximize received signal power. For this project, I use Yagi-Uda antenna. Radiator, reflector, director, the element lengths, and the distances between them are all independent variables. The antenna gain in a particular direction and radiation pattern are dependent variables. So here are the materials. We have popsicle sticks, and then we have copper wire. We also have copper sheets and a soldering iron over here. And finally, we have a Wi-Fi router to connect our antenna to. First, I built the monopole antenna. I cut the copper sheet into half the Wi-Fi wavelength of 61.5 millimeters. I then drilled a hole through the center and stuck a coaxial cable with one side shaved off with a wire stripper. Over here, I can be seen testing the antenna with a monopole antenna on the tripod and me with my computer 2 meters away. The theta graph is relatively isotropic as expected, while the phi graph shows two large lobes. I spent some time building various Yagi-Uda antennas, changing my independent variables. One of those independent variables was the reflector size. Although I had 65 millimeters before, 63 millimeters seemed to produce a stronger and more defined radiation pattern, so I chose that instead. Also, the tested data wasn't actually as accurate as the simulated data, which can be easily explained by these two misaligned dipoles. We can imagine that two angle dipoles with different angles can produce different polarizations of electromagnetic waves, which will reduce the power emitted. Finally, I concluded that a radiator length of 0.475 lambda, a reflector length of 0.55 lambda, and a director length of 0.45 lambda gave the maximum gain of 8 dB in the wanted direction. Over here we can see that these three antennas all have about 8 dB, while this one has the lowest gain. However, when we measure the path loss, this one easily seems to have the lowest path loss. So this is our antenna.